Example 4.5 is going to show us how to use relationships between tangent and secant to solve integrals involving tangent and secant. Namely, the relationship is kind of a Pythagorean identity sort of looking thing. Tangent squared is equal to secant squared minus 1. We should also use the fact that if we differentiate tangent, we get a secant squared of x, which of course means that if we anti-differentiate a secant squared, we end up back at tangent. So let's work on the integral of the fourth power of tangent. And I'll rewrite this as tangent squared times another tangent squared. So that way I can use the relationship above that says tangent squared is equal to secant squared minus 1. So let's substitute. Actually, sorry, before we substitute, let's distribute and write this as two different integrals. Secant squared times a tangent squared minus integral tangent squared. All right, this first integral is a substitution problem. If we choose to substitute tangent, then the derivative of tangent is our secant squared. So secant squared dx is replaced by a du, and this integral becomes integral u squared du. This integral of tangent squared, needs a little bit more work. We should rewrite that tangent squared as a secant squared minus 1, because the antiderivative of secant squared is known. Secant squared will anti-differentiate back to tangent. So this becomes 1/3 u cubed minus the integral of secant squared is tangent. And when we distribute this negative, the integral of 1 becomes x. And we have our constant of anti-differentiation at the end.